Thank you for taking the time to join us today. And we are excited to be coming to you live for Tech Talk Tuesday. So it's the top of the hour. Let's get rolling.
Yeah. And this would be, I guess, our official episode 1, because the episode that we did a couple of weeks ago was unofficial, saying hello, transitioning. So this would be officially episode 1 of season 3 of Tech Talk Tuesday. And if there's any new people joining us today, all the old episodes are available on the YouTube channel under Baseline Web Training. That's all one word, Baseline Web Training on YouTube, as well as lots of other helpful videos that Dan Conger, training manager, has been producing over the last weeks, months, etc. And our topic for today is Got Pumps. And we're going to talk kind of at the higher level. So this isn't really going to be exactly how to, integrate and set up and program, but we're going to talk a little bit about sort of our philosophy as it relates to pump stations and pumps and water sources and such. So Chris has a slide deck he's going to share, and we're going to have a conversation today. And we would love to know from you guys that have, worked with both booster pumps and pump stations, what your biggest probably, the problems that you see out there, what doesn't work right. As we go through this, we'd love to know what the pain points are, what doesn't work right. And that could probably add to our conversation today.
For sure. Yes. We know that pump stations are a necessary part of an irrigation system. And we also acknowledge that, pumping is a rather complex process. And there is definite technology behind a pump implementation. And, we want to speak to how Baseline interacts with a pump station and what the advantages are with the base station controller actually controlling the hydraulic structure when there's a pump station associated with it. So if we think of it in terms of pump station management, a pump works in conjunction with a baseline controller to fulfill the watering demands of a hydraulic structure.
Right.
So what does that mean, Andy?
Right. Should we say this in layman terms, in contractor terms?
Sure.
The pump puts water in the pipe.
Yep. That's about as simple as it gets, right? So pump is providing water to the hydraulic structure from the water source. And we know that there's several different applications and scenarios for that. So we want to address that and speak to it. Okay. So as we look at water source management, this is one of the things that occurred to me in preparing for this, Andy. And it also occurred to me in preparing for this that we haven't done a Tech Talk Tuesday speaking to pumps and pump utilization with the baseline system before.
It's true. We've talked about water sources and priorities and such. We haven't really talked about pumps.
Right.
Pumps.
Exactly. And we've got, some pretty common vernacular in the industry for water source indicator, right? As a primary or a secondary source. And it occurred to me that, we often talk about secondary water sources, i.e. being, something other than a municipal source, but who's to say what is a primary and what's a secondary water source? Maybe your secondary water source is actually your primary water source or the only water source available.
Yeah, that's totally true, because we say secondary oftentimes meaning just two sources. However, a lot of times that secondary source, that cistern, that retention pond, that lake, the well, whatever it might be, is priority one. We want to use it first. And if it's not available, move to our secondary source. And oftentimes that is the city municipal source.
Can be correct. Yep. So regardless of primary or secondary, baseline controls the water in the hydraulic structure, right? The pump gets the water into the hydraulic structure. Then from there, baseline really controls the operation of the system to fulfill that demand requirement coming from the water source and the pump station.
Really kind of another way to look at it is downstream of the pump station. A majority of the time, the pump station is blind. It doesn't know why a certain amount of gallons is running through the pipe. It doesn't know where it's going. It doesn't know how long it needs to run. It's just essentially reactive. It's just filling the pipe with water based on what the base station controller is asking it to do, because the base station controller is in charge of the water. It's controlling the water.
Correct. Yep. And the pump doesn't know how the controller is programmed, right? And that can create some behavior that is challenging and or unexpected and or downright frustrating for the irrigation manager when interfacing with a pump station, right? And so one of the most common issues is what happens if there is a pump fault on a system, right? Does the controller know that there's a pump fault? What's the behavior of the controller? Does it continue to operate like it thinks that there's water available, or does it shut down?
Right. Yeah. I mean, let's give a real scenario. Let's say that the pump is pulling out of a lake or a secondary source or a retention pond, and there's not enough water. It's out of water. And if that's the only source, the irrigation controller may not know. It just knows it's running and there's no flow happening. And if you haven't set up the baseline controller with any of those parameters, it may look like it had a 60-minute runtime and it ran all day long, but no water was coming out because the source was empty, because the two aren't working together in parallel.
Correct. Yep. And oftentimes the pump station will have a design flow associated with it. And if the controller gets programmed to operate a number of zones at the same time that's above that pump's capacity or delivery capability, the pump really doesn't know that unless we've got certain flow thresholds set up in the control system, which will then activate the pump shutdown based on those different thresholds and parameters.
Yeah. And pressure being the one we'll get to in a moment. So continuing with that just quick example, if there's no water in the pipe, the pressure would drop. So we could see that and have a condition exist, as well as look back, historically and see when did that occur. But we need to have that kind of visibility. And historically, a controller that didn't have any sensor devices connected to it had no visibility on really what was happening downstream either. But now that we can, and we have these sensing devices, we can see, really as much detail with as much resolution as we want to design for downstream of the pump station.
Yeah. So what are some of those sensors?
Yeah. Well, we've got our traditional flow sensor, right? And depending how you want to have them installed, you could have one, and you could also have 8 sensors, and it could still be 8 sensors on one pump station. You could put them downstream from each other and utilize the flow station and have, in series, if you will, flow sensors for better resolution. And then with the addition of the pressure sensors, the same thing is true. You can have your pressure sensor at the source, or you can add them downstream in series.
Yep. And you bring up something to be, to remind everybody of. One of the key capabilities of a baseline control system is that ability to start, stop, and pause, right? So in typical or conventional use of a pump station, we're starting the system and then we're stopping the system, right? But what if we throw a pause into that algorithm? What's the behavior and how do we manage that efficiently so that the pump station knows how to react to those pauses that may occur?
Yeah. And it can be another good point, because there could be a condition that we want to pause, and it could be an operating condition actually of the pump station. Maybe rather than stop, if the pressure gets too low, we want to pause because maybe there's some kind of like replenishment happening in this lake example. So we want to pause the control system for a period of time while the water fills up so that we can re-engage the pump station, say 2 hours later. And all that logic can now be sort of front loaded into the irrigation controller instead of being sort of as it was historically, where it's all in the pump station and the irrigation controller has no, idea what's happening.
Correct. Yep. Excellent. So definitely some complexity associated with it, right? So if we look at the different types of pumps that we usually interface with, we've got a pump station or we've got a booster pump, right? And depending on the application and what the water source is, it may be just one or the other, or it could be both at the same time as well, right? So with a pump station, it's putting water into that hydraulic structure, and that water is coming from groundwater, surface water, cistern water, all of which we've mentioned already. But there's some, recommended components that we feel the controller needs to have direct optics on and be direct wired to. And that is the pump start relay, if required, the flow sensor, and the pressure transducer. Now, many pump stations come pre-installed with a flow sensor and a pressure transducer, but are those always associated or provided because of the irrigation control system, or are they provided in benefit the pump station itself?
Generally always to benefit the pump station, so they can operate as engineered and can protect itself for its own alarm conditions to save its own pumping system. We can connect to those devices, and utilize them, or we could add our own in combination with that. But I think the important thing is we should remember that whatever the pump has for its operating parameters, we need to take that in consideration when setting up the flow requirements of the irrigation system.
For sure. Yep. So we want to make sure that we've got, for those flow requirements, that we've got a flow sensor that's directly wired to the control system that is measuring and monitoring flow, not only for the, shutdown capabilities, but also for the irrigation management capabilities, i.e. number of zones to be operated at one time, et cetera. Right.
Yeah. So, keep in mind too, if it's a retrofit, a lot of these pump stations aren't where the controller is. They might be on the entire other side of the park or the ball field complex. And if you utilize a wireless substation, you could put a substation down at the pump station and put these devices there and retrofit into it without running new wire all the way out.
Yeah. And we've had a couple of conversations in the past where, typically a pressure transducer is installed on the pump station, but we've, worked with designers to provide a pressure transducer on the hydraulic structure as well, i.e. on the main line of the irrigation system downstream from the pump station that is dedicated to the controller itself, correct?
Yeah. Because we would want to save a potential call out to the site. If the pump alarms really, a lot of times you got to go out there and manually override it. And it could be that you got to go out there anyway, but if we can take the alarm system into consideration, we can turn down the irrigation system, if you will, decommission the irrigation if we see the problem, so that the pump just turns itself off, but then there's no alarm conditioning happening in the pump. We've seen it, we've sensed it, we've reacted to it.
All right. So you bring up an interesting point, and one of the unique capabilities of a baseline system too is what we refer to as an integration with a pump station, right? So many of you are aware, likely, or maybe using a Monroe pump station with a base station 3200 controller, right? And we do have a certain level of integration with that pump station. But Andy, is it, an operational integration, or is it more an alert and messaging and reporting?
Yeah, that's a great way to say it. It's messaging and alert integration. Because we can't actually make any control decisions at the pump station. We can't turn anything on, off, pause, start, stop. We can read the pressure, the real-time pressure, historical pressure, and we can see the alarms that are active on the pump station. And that's really what the integration is all about, is it's reading those alarms and alert conditions that are on the pump station, should there be any.
Yep.
And there's no decision-making happening.
No. And the pump station's got its own VFD associated, which we're plugged into, right? That allows us to see that pump data as well as be able to display the pump curve over time on the display of the controller. And then it also allows us to, through Base Manager, notify the user of those alerts and alarms that may be associated with the pump station.
Yep.
Right.
Yep.
Very cool. All right. So great relationship, and it's worked very well for us in specification, and just like to continue to speak to it and clarify what that integration includes.
Yeah, and it's important to realize too that we put it out there in the world, and there's only so many engineering hours at the company, right? So there's a decision that has to be made of where to put engineering hours.
Never as many as we want.
Yeah. And so, version 1 went out with Monroe, and it's really what it still is, because engineering went to all these other projects to develop all these other products that we currently have coming out and have produced over the last 4 or 5 years.
Correct.
And the Monroe is like integration version 1.
Yeah. Yep, for sure. So, all right. So going beyond a pump station, if we were to look at booster pumps, boosters pump, real priority is to add flow or pressure to a hydraulic structure, right? And that may come in different ways from different sources. If you've got a municipal source of water that's pressurized, but it's not enough pressure to optimize the performance of your sprinkler system, we can add a booster pump to increase that pressure to enhance, sprinkler performance.
Yeah. And the key part there is to, the pump start relay is the component. It's only necessary if it is going to be a pump start activation. If it's an on-demand system or a pressure activated system, then the pump just kicks on when pressure drops, and that's built into the pressure start. So you wouldn't need a pump start relay. And maybe the furthest we'll get in the weeds is just to remind everyone that when you use a pump start relay, you should have a secondary 24-volt power source to activate that relay. So a lot of people don't realize that. So just keep that into consideration. You can find all the wiring documents on the website, but some people miss that.
Yeah. Yeah. So in thinking about it, question for you. So with a pump station versus a booster pump, we have the ability to assign a booster pump just to specific programs, right?
True.
Because there may be programs that are operating, large turf rotors that need more pressure, but that controller may be also operating drip programs where the standard static or dynamic pressure from the water source is adequate enough.
Yeah.
So how does that work in the programming?
Yeah, totally. And a great example of that would be some synthetic athletic fields that we've done that require much greater pressure for those big guns.
Yeah.
And then where that same water source also feeds the landscaping, around the facility, the city street pressure is adequate. And so inside of the schedule setup, you can make the booster pump specific to that schedule. So any of the zones in that schedule, program 1, receive the booster pump comes on. Every other schedule or program, they don't come on. It doesn't turn on.
Yep. So some good capabilities there, and allows us to tailor the pressure needs to the sprinkler type or volume needed.
Yeah, and sometimes there are ranges that pumps like to work within, and so if there was a very small zone that the pressure could be as low as 30 or 35 because it's a drip zone, you might not need the pump. So you can really design your pump for where it's required, and then just have it either being used or not being used per program.
Definitely. Very cool. All right. So let's look at a couple of different design scenarios, right? Those design scenarios may be simple as a 1-to-1, i.e. one pump station to one controller, or it could be, one to many, and it could be one to many either way. Maybe one pump station to many controllers, or one controller to many pump stations, right?
Yeah. And this is really like, if you guys remember one thing from today's tech talk as it relates to pumps, it's that as soon as you add a second water source, that's where the power of having a controller like Baseline becomes really valuable, because now the irrigation controller is in charge of this whole, like Chris said, this whole hydraulic system. And so it can decide which pump is running, which one is off, which is on, what's the priority, when to switch. And historically, that information had to be programmed into a really expensive pump station that managed these two different sources and then fed one supply into the main line. And that whole logic was in the pump station. And now with our, multiple water sources, priority, start, stop, pause, we can really be in charge of all of those sources.
Definitely. Yep. So if we look at this, hydraulic layout as an example, this may be real or it may not be real, but I've certainly worked on projects where this is pretty close to, what challenge we were faced with. And then we were able to provide the engineered solution to.
Yeah, and it's real. I see someone on here right now, Paul, I see you. And I know you have a system in Minnesota that has two of these. It doesn't have a cistern, but it has a city source and it has the surface water source. So
for sure
stuff.
Yep. So, and the thing that's unique about, the Baseline system in managing a structure like this is that, likely obviously the surface water and the cistern are going to have a pump associated with them, right? Unless the surface water is at an elevation that's far above the site where gravity is generating enough pressure into the main line to operate.
Like a water tower. Is that what you're saying?
Or we do have some projects in Colorado where we've got that kind of geographical change in elevation. But the point is that, depending on the demand of the zones operating off of different main lines, we may be operating, just one, two, or all three of these different water sources in order to deliver enough water to those zones that are requiring irrigation scheduling. And being able to do that efficiently can be, very difficult. So as what we've done is tried to engineer it so that we can manage it in a pretty simple interface that can be configured to handle that. So in this kind of a scenario, we would definitely need a flow station in order to manage this, because we've got, dynamic flow allocation and control point grouping going on at the same time.
Yeah. And there's a lot of information on this particular slide. If we were to break it down and say we're only using the cistern, what that's saying is we only have 20 gallons a minute. That's it.
Yep.
So then the Baseline controller knows I only have 20 gallons a minute. I'm only able to operate, up to that. So maybe that's one zone that's 18 gallons a minute, or maybe it's, 3 zones that are 6 gallons a minute each, but it knows it only has 20 gallons a minute. So it can continue operating correctly based on the data that it's getting there. Right. If you add a second one, the surface water, then you would have 80, and then it would know I have more water available. I can turn on more zones at once. And then if you add the third source, then it would know that it has its full 100 capability. Even though it's more water, it's limited by that 3-inch main line of 100 gallons a minute.
Correct.
And it can take all that into consideration in real time and manage this whole entire system.
And manage any of the pumps that are associated with it. Correct? Yep. So, this is obviously a engineered solution that you would work with the regional manager with Baseline to help configure and design. But it's important to note that we do have this capability. All right. If we look at a larger scale, a project that we've been involved with in Colorado, large parks department, city of Westminster, they have, this one super park is a good way to describe it, within the city that is getting its water from the city's pressurized secondary or effluent water source. So the picture shows this pump room that is supplying this pressurized secondary water to all commercial and parks sites in within the city for landscape use. And when the city of Westminster irrigated and lit up this one park site, the water managers from the city came to the parks department and said, hey, you're using too much water at night that is impacting the pressure on the entire system, which is affecting the water availability and performance of commercial properties that you share this water source from. So if the city was using 10 million gallons a night, the cities were using in excess of 10% of that water, which was impacting other users. So we were able to work with them to develop a configuration and a programming scenario where we were managing the peak demand within the hours of 10 p.m. and 2 a.m. And so the setup essentially is based on priorities of control points and size of control points and the volume of water that they're able to deliver through each one of those control points. And basically from 7 to 10 p.m., the park had 900 gallons per minute available to them. But during that peak demand time period of 10 p.m. to 2 a.m., they wanted to throttle back the usage on that park site to less than 500 gallons to ensure that there was enough water and pressure available for all the commercial properties as well.
And right there, Chris, that's the difference between a sprinkling system and an engineered irrigation solution.
Definitely. Yep. So this is something that we'll be speaking to more frequently, not only on the specification and design level, but also with our municipal users in helping them to manage these kinds of scenarios, right? And it takes a sophisticated algorithm within the control system, different sensors working together, give us that real-time data that makes this all possible.
Even just, I mean, a lot of times the surface water systems that are out there, thinking about the system that Paul has in Minnesota, they're not utilized all of the time because the technology wasn't there to just do it sort of properly. And so we want to use those sources like surface water as much as possible. Use all of it until the sensor says it's dry, right? Then switch over to municipal water.
Yep, very much so. Awesome. All right. So we've got a couple of comments coming in. We like the fact that we're making you think about some of these, ancillary type programming conditions where we can manage different sources correctly and manage those peak demands. So if you want assistance on, the configuration behind any of them, please get in touch with us and we'd love to have that conversation.
Mm-hmm.
Right. All right.
And appreciate the showing, guys. It's great to see everyone and happy that everybody migrated over from the old system to the new system.
Absolutely. Yeah, that seemed to go pretty smooth. So our next live session is going to be on February 22nd. Hopefully you are taking advantage of the on-demand and live training sessions that are happening as part of Tech Talk Tuesday as well each month. And we will make sure to prepare another great and informative session for you live with Chris and Andy on the 22nd of this month. So very good.
Thanks, guys.
Appreciate it. Have a great day. Go out, work hard, be safe. Bye-bye.
Take care.